In this tutorial we will use a ppm file, and I guess you can use any other image file like PNG or JPEG or something like that. But this one will be very easy to work with because we don't need any special function. We can open it as a text file, and as a text file it looks like this. This is the type of encoding. This number is the width, so it's 300 pixels. So 300 pixels. Hope maybe you can see the number 300. And then 400 pixels is in the height, and 255 is number of colors per individual RGB value, so for individual subpixel. So it's from 0 to 255. And then there is this kind of stream of letters, and those are the RGB values. So this is the R value, G value, B value, R value, G value, B value, and so on and so on. And these are the thing is it's a display this way because that's how the text editor is set to show the values. But if I try to print these characters as integers, they would be values from 0 to 255, and this is, I guess, the ASCII character of value, maybe, I don't know, 75 or something like that. So we can then directly take the values as integers, and then we can use the algorithm on it directly. And yeah, so we will need individual lines, so that would be 3 times 300, so 900 characters is one line of pixels in the image. And this will be the structure of our code. There will be one main function which will just read the file and create a new file. This one will be the input and the output file. In this part I will just take the characters, so the width and height of the image, so that would be these characters, and then this part. So there's the width, height, and I will store the height, and then I will store this value, and then I will this is just to get rid of some of the parts of the code, parts of the text file, and then I will run the Floyd-Steinberg algorithm, and then I will close the files and exit to shell, so the program doesn't, so I don't have to close it manually every time. And I will not do any compression to black and white, so I will output the image in the same format. So then there will be 3 same values, either 0 or 255, then again 3 zeros or 355 for the black and white image. And again, it's for the educational purpose, so it's easier You can then change the code as you wish for your use case. So I think we can start now with the programming. Oh, yeah, maybe I can show it now. There would be maybe a problem with loading the whole image into the memory, especially on older machines. So we will do, instead of that, we will always take one row of the values, and that one will be then stored in, and then we will have two rows with the errors, and those rows we will then swap here at the end. And in this way it will be much more memory efficient, because for all the calculations we always need just to load the one row of the new values, which is 3 times the width, because there are 3 subpixels for every pixel, and these are the values, the characters. And then we need always just 2 errors, the error which is propagated on the first line, and then on the line below, and the line below will become in the next run the line above, and this way we will recreate the new image. So I think we can now start with the programming part. So we can start with the new project, file, new, and let's call it Dithering. Yeah, we can store it on the desktop. macOS C, C++ stationery, and I will use the toolbox and multi-target, although I will use only a console. I want the toolbox functions like exit to shell. I guess that's maybe the only one, but I will use it for the application to quit at the end. So Dithering, and resources, we won't need any resources, so there is the syllables application, which is there always, and there is the C file, so I will create my new file, new text file, and I will save it as main.c in the Dithering folder. Save. Now I will move it a bit to the side. And project, add files, Dithering main C. And now I will remove this one with command backspace. Okay. I guess I can also get rid of these resources, and I'll also get rid of these files here. So now let's create the main function. So I guess I will include some libraries. Include standard library std and include std integer age main function turn 0 and just test if it's all working. So I have a working application. Now let's see. Exit to shell. Don't save. So you can see how annoying it will be a few moments. So that's why I will use the exit to shell. So now when I compile it, runs, you could see that it kind of created the window and then it exited. So this is, I guess, fine. Now, so we will need the input image. I have it somewhere. Input, and I will put it in the Dithering folder. So now when I run the application, there is, it's like here. Yeah, so it's in the folder. It's just quite far. It's a list. Now you can see that in the folder there is the input.pem file. I can't open it here, so that gives me an error, and I didn't found a program which would work there, but I guess I will then show it in the preview on my main computer. So we will need the width and height, and the pointer to the file, to the input image, pointer to a file to the output image, this is opening the file, and I will close the file, open file, put image is f open input.ppm and read, and output image is f open output.ppm with write semicolon, and okay, maybe this opening of the files is here, and I will close the files here. Close f close input image and f close output image. So we can try this code if it works. Yeah, sure. It's not used, but it ran without an error. And if I go to the dithering, it create the output image, output.ppm. So it seems it kind of works. So now we will store the file header into the file, and for that we will I guess we can do it this way. We will get a character from the input image, and we will put this character into the output image. That, and we will use this line of code 3 times. So this is the this part of the file. First character, second character. This is the third character. And now we will store the height. F scan F from the input image, integer at the address of height. Yeah, I was saying that it's firstly it's the width. Yes. And height, width, height, and now we will store it in the output file. So printf to the output image %p with the semicon and the height, and we will also need the new line character. And then there will be the number of colors, so that's 255, and the new character, and that's it. Now we will get rid of the new character 255 new character part. So I guess I will just use this part 4 times for all the characters. For this, I got rid of the first new character with the reading the scanf. Did I? Maybe not. Maybe I will need it 5 times. We'll need it 5 times. And now there will be the Floyd-Steinberg, and then it's done. So we have the basic part. So let's see if it works. So it seems this part works correctly. Okay. So we can go to the Floyd-Steinberg algorithm. We will need pointers to the input and output image. output image and integer width and integer height. Input image, output image, width, height, and that will be our function turn 0. Cool. So in this function we will need the some x value and y value, which will be in the for loop. Y value is for all the rows, x value is in the row, and in this version of C we need to declare all the variables up front. Then we will need the pointers for the errors, so there will be a pointer to array of floats errors and errors next, and one for the switching, which will be just a temporary, so maybe like that. And we will also need 8 pointer for image. So this one will be where we load all the values for one row of pixels, and these are for the errors which will be used for the algorithm. And we will need some old value and new value as was in the presentation. So that would be float old value and float new value. And the new value is the one which will be stored, so we will store it as the int 8. Here we should be careful with the integer because maybe on different machines the integer value would be different depending on the architecture, and maybe you want to use the program on the old Macintoshes, so that would be 32-bit, but sometimes they are the 16-bit, so I'm not sure, and that's why I will use this way directly the 8-bit integer. So now we can allocate some memory for the errors and for the image. So yeah, allocate memory on heap where the values will be stored. So colloc with size of float and we should check if the allocation was done correctly. Print f error. Errors. Next. And I'm doing this approach with the one row memory because I tried the program with the whole image stored in the memory, and I wasn't able to allocate enough memory. I think I set the limit here to smaller value because it had a problem before. So but with this approach, there was no problem with the memory allocation. And image equals malloc width times 3 times size of O int 8. This way. So for the errors, I want to prepare the memory so there are only zeros. For the image, it doesn't matter because I will change all the values with the first run. And again, image something like that. Now I can go to the for loops where I will do the algorithm itself. So for y equals 0, while it's smaller than the height, y plus plus. So this is the outer loop for going through the rows, and then there will be the inner loop for x equals 0, x is smaller than width x plus plus. This is the inner loop. So we have the loops, and here I will need to load the whole array of values into the image image array. So that would be freed into the image array width times 3 because there are 3 colors. And from the input image. I'm not sure what this one is right now, but I guess you can go to the documentation. Okay, so there will be some stuff going on, and I will do this swapping of the pointers of the errors at the end. So these are the errors next. Errors next will be the errors. And the errors on the current line will be the from the temporary errors, which are the errors next from the previous iteration. And here the thing is, I don't need the values of the errors from the current line because the propagation is only one way, and I can then overwrite all of these values which were in the errors as for the errors next. Should I try the code? Maybe I can. Only warnings that I don't use some values, so that's fine. I will use the values now. So the old value will be from the image x plus, we'll comment on this later, plus 1 plus 2 divided by 3. So I will take the value from the, because here there are still the RGB values. The x is just the x position of the pixel, but I need also with the image line, I need to get there with the correct subpixel. So if I am in the first pixel, then it would be 0 x, and I have values 0, 1, 2. If I'm in the next pixel, the x is 1, then it's the third, fourth, and fifth, and this way I get the RGB, and I divide it by 3 to get the grayscale image from the RGB. And I will have to add the error as it was in the presentation. So from the errors on the current position. Maybe I can I have error on the current position, and that's the old value. Now I should decide what is the new value. So the new value will be so the old value, if it's greater than or equal to 228. So this is the part which does the what did I call it? The thresholding. So I do the thresholding, but this is true and false value. But if it's true, then it's 1, and I can multiply it by 255. And if it's false, then it's 0, and times 255, it will still be 0. So this is kind of a trick how to do the thresholding and how to get the new value in the same range from 0 to 255. Grayscale, and I have the new value, so I can just store the value into the file. So I will put character int t new value into the output image, and I will do that 3 times because I have three RGB values, and I want them to be there stored in the RGB format. So I need for red, green, and for blue. And I am also changing the type to uint8. I'm not sure if it was there, just to be sure. So now this is fine, and it creates this program would create the image in the black and white way, but I now need change of these errors, and this will be a bit maybe tricky, but hopefully it will work just fine. So if x plus 1 is smaller than the width, so if I have not reached the end of the line, the errors on x plus 1 position will be the errors on the x plus 1 position plus error current, or something like that. So I would have to kind of think about how to create, how to find the error, but I guess you already know. it will be the difference. So I can, I guess, okay, error and times the 7 divided by 16, which was in the matrix the multiplier of the error. So instead of saving the error somewhere, we can create a function which will just output the difference of the two values, or I could put the difference of the old value and new value there, and that would be perfectly fine, but it would be a bit not nice, I would say, maybe a bit confusing, and then the line would get too long. So I will go up and define error function of new value, old value as old value minus new value. Like that. And this is for the line of the current errors, and now I will need for the next line of errors for the errors next part. So if y plus 1 is smaller than the height, so if I can do something and I am not in the last line, then let's see, so there were the 3 pixels below the current pixel, but maybe with the first pixel I could also be in the out of the range. So if x is greater than 0, so if it's not the first one, then errors next at the x minus 1 position would be this, plus the error times 3 divided by 16. And if I am on the first position, so that would be else, then on the x position is 0. So I will reset this value to 0, and I will set some value there in one line of code here. So errors next on the x position is plus the change there is not 3 but 5. So I need always to reset all the new errors to 0 somewhere, and I will do that in the last part, which would be for the next element. So if x plus 1 is smaller than the width, then errors next on the x plus 1 position is the error times 1 divided by 16. So the thing is, in all these cases, I take the value and I add to that the error. And the problem would be if I had if I didn't reset the values to zeros, so I would just adding the values and then it would get out of the scope what I can store there, and I would have some overflow. So for that, here, for all the new pixels, I will just set the value and I am not adding something. So this is the resetting to 0, and then so it would be like set this value to 0 and then add the error to that, and then I can just add the error here and add the error here. But I would have a problem for the first pixel, which I didn't reset anywhere, because I can't get to that with the x plus 1 position, because then that would mean I have to be on the minus first position to do the resetting here on the first position. So for that I need to reset the value here directly, and then I can use this line, same for the first pixel and for the rest of the image. So this is fine, I guess. And we should also free all the arrays which we have. So free image, the end, free errors, and free errors next. Then we return 0. Line 120. Sure. Semicolon is missing here. One is missing here. Maybe this is enough. Did it work? Okay, so I will this guy into trash. Oh, run the application. Now it does something, and I have a file. Probably it did something, so I will show that on the uh, on the on my normal computer, and we will see if it works. So I've moved it to this folder, and let's see how it works. And I think it worked quite nicely, and you can see the dithering there. So you can see there is, I like this kind of texture that the Floyd-Steinberg algorithm does. And yeah, I think this is nice result, and you can use this algorithm now everywhere you want. And I will share the code on GitHub, and there will be a link below the video, so you can just take the code and download it and use as you wish. So I hope you liked this video, and if it was helpful, share it with your friends, or if you think it was not helpful, then share the video with your enemies, I guess. So see you.